How's it going, students? Here's the video for the study guide. Once again, you guys can use this on the actual test. So thank you for completing this. All right, so question number one. I guess before we do that, we have to construct a dot plot using the given data. All right, so I see we have a bunch of, let's see, 16, 17, 18, 19, let's see, goals all the way up to 28. So we definitely need all those numbers, right? So let's just go ahead and count by twos. We'll start at 16, go up by twos, 18, 20, 22, 24, 26, and then all the way up until 28. All right, so 16 dot plots, we need to represent each of those employees with a dot. Right, so how many employees do we have? Are 16. Let's see, we have 1, 2, 3, 4. 4 employees, so they get 4 dots. 1, 2, 3, and 4. All right, how many employees are 17? We have 1 right here. We have 2. Yeah, 2 employees are 17, so that goes on that. Right, making sure they're both evenly spaced as the 16 column. How many employees are 18? Let's go ahead and cross them out. 1, 2, 3. 3 employees are 18. So we draw 3 dots. Let's see, 19-year-olds, we have 1, 2. How many employees are 20? Well, there's none, so we just leave that empty. 21, there's 1, 2 employees that are 21. And then our last 2 employees are both 27 and then 28. So we have to put 1 dot for each of them all the way over there. All right, so we constructed our dot plot. So let's go ahead and answer question 1. Using the dot plot above, determine how many workers are 17. Well, you would just simply look at that column or the I guess the height of the dots for 17. We would say there's 2 workers. All right, question number 2. Using the dot plot above, determine the percentage of workers that are older than 20 years old. Round to the nearest whole percentage. All right, percentage of workers that are older than 20 years old. So once again, I know I've said this a lot in class, but we need to use this part over the total. All right, so let's think about what total do we need? Well, we need the total number of workers. And then in our numerator, what does this part mean? Well, what part of the total do we need? Well, we want the part of workers that are older than 20 years old. So number of workers older than 20. If we look at our dot plot, we can see that it would be, let's see, 1, 2, 3, 4. So number of workers older than 20 would be 4. Now, total number of workers would be 15, they tell us, or if you go ahead and count all these dots, they should total 15. 4 divided by 15. Let's see, that would be 0.2666 repeated, but we don't have to worry about that because we just want to round to the nearest whole percentage. So if you forgot how to make this into a percentage, remember we move this decimal place twice. So that would be equal to 26.6%. percent, rounding to the nearest percentage, right? So we should have no decimals. When this is 5 or above, clearly that's 5 or above, we round it up to 27%. 27% final answer. All right, number 3, all employees that are 18 or younger are still in high school. Using the dot plot above, determine how many high school students were just hired. So they tell us that high school students are 18 or younger. So we just have to go ahead and count how many of those employees are 18 or younger. So that would be, let's start off at 18. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 workers. All right, number 4, the manager said the majority of the workers are 16 years old. Is this a true or a false statement? So if we look at our dot plot, 16 years old, it looks like we have the most amount of workers that are 16 years old. But that's not what the question is asking us, right? The question is asking us whether a majority of the workers are 16 years old. If we think about the word majority, we need greater than 50%. Majority, greater than 50%. So, you could do this mentally, right? Clearly, 4 out of 15 is not going to be greater than 15%. So yeah, this would be false. False. Explain your answer to number 4. Well, 4 out of 15 workers is not greater than 50%. And I'm just going to write in parentheses, or it's not a majority. All right, moving on to question number 6. Let's see. If a passing score is 71 or higher, how many students pass the test? So we need to go ahead and use this histogram. Let's see, passing 71 or higher. We can find out those scores by looking at, not scores. We can find out how many students pass the test by looking at each of these bars, right? So some of you may say, well, the students that have 70 through 80, that would be 8. But what else do we need to add? We also need to add this column and this column, right? Because we need all the scores that are greater than 70. Clearly, 81 through 90 is greater than 70, and 91 through 100 is greater than 70. So adding all those up, that first column would be 8. This bar is 12. And this bar would be 6. So 8 plus 12 plus 6, that gives us 26. All right, how many students took the test? Well, we already know that all of this would be 26, this one, and this one. So let's go ahead and add this and this to it. So let's see, 26 plus this height of 2 plus this height of 5. That gives us 26 plus 2 is 28. 28 plus 5 is 33. All right, moving right along. Question number 8. Let's see, question number 8. We need to use the following data to answer these questions. So Roxanne earned the following scores on her biology test. So what is the mean of the data? All right, as you guys know, with mean, we have to go ahead and add up all of those scores first. So we literally add 88, 67, 75, 80, and 75. Adding those up, we get 1 second. Sorry, I thought I had written it down before, but anyways, I just went ahead and calculated that. That was 385. After we add it all up, we have to divide by the amount of numbers within the data set. So dividing by 5, 385 divided by 5, we get our mean. That's going to give us 77. All right, number 9, the mode. Remember, the mode is just the number that appears the most. So the number that appears the most in this data set would be 75 because it appears twice. So 75. All right, number 10, the median. So on this question, a lot of you, if you saw this on the test, a lot of you would make the mistake of basically just going and finding the middle number out of this data set. But remember, we need to go ahead and rearrange them in order from least to greatest. So let's go ahead and do that first. 67. Next one would be 75. Next number would be 75. Next number would be 80. And then finally 88. So only then can you find the median. So the median is literally the middle number. The middle number is 75. So you guys notice that, well, if you did make the mistake and just found the middle number earlier without rearranging it, you'll still get the same answer. But that's probably not going to be the same on the test. On the test, it may not end up that way. So we were just lucky here. But anyways, 75 is our median. Number 11, what's the range? Remember, students, the range is just the maximum minus the minimum. So we would just subtract 88 minus 67. That gives us an answer of 21 for our range. All right, question number 12. What is a better measure of central tendency for this data? The mean or the median? Right, if you guys remember measures of central tendency, we can measure it using the mean or the median. So which of these measures our center better? And for this one, the answer would be the mean. And I'll explain why. If you think back to our lesson on measures of central tendency, we thought about outliers. So outliers. Remember, if outliers are present in our data set, the outliers affect the mean. Right? If that doesn't make sense, go ahead and turn back to your lesson or your packet, and it should make more sense once you look over that. But outliers affect the mean because they're far away from our normal numbers, right? So they're either going to pull the mean down or they're going to pull the mean up. So basically, this question, the answer is mean because there are no outliers present. So let's just go ahead and write that down. Explain your answer to number 12. Mean because no outliers are in our data set. Right? So I'm just going to put it as just a side note. If there are outliers, the median would be better to use. All right, if there are outliers, the median would be better to use. All right, moving on to questions number 14 through 16. And we need to use these box plots that they give us. So, all right, 14, which plot has a smaller range? So it's not asking you what the ranges are, it's asking you which one has a smaller range. If you guys remember, the range is basically the maximum minus the minimum. So basically, just by looking at this, we know that this is our maximum, this is our minimum, and with this plot, this is our maximum, this is our minimum. So which one has the shortest distance, right? Which one has the smallest range? And clearly that would be part A. From here to here is clearly shorter than from here to here. So which plot has a smaller range? A. All right, 15. What is the median of each set? All right, remember, when we do a box and whisker plot, the median is literally this middle line right here. So the median of each set, well, they both line up at 70. So 70. All right, number 16. What percent of the data in plot A is greater than 80? All right, so this one's a little bit tricky. But first, let's think about what exactly the median and the quartiles do. So for instance, let's just say we had a list of numbers represented by this line. If we take the median of all those numbers, let's go ahead and let me just write this out. This is our median. The median would split these numbers in half, right? That's literally what the median does. We find the middle of it. So this half would be 50%. And then this half would be 50%. All right, so after we take the median, we go ahead and find the quartile 1. Finding quartile 1, let's just say this was quartile 1. That would split this 50% in half again, right? Because that's just how we find the quartile 1. So basically splitting this 50% in half. This part, let me just try to draw a line more further. This part would be 25%. And then this part would be 25%. All right, and then quartile 3. Hopefully you guys see where I'm going with this. Quartile 3, once again, this half is 50%, and quartile 3, we're just splitting it in half again. So let me go ahead and draw this out. This is going to be 25% once again, and then this is going to be 25%. So why exactly did I show you guys this? Well, if we look at plot A, our quartile 1s, our median, and our quartile 3 are represented by each of this, right? This is our quartile 1. That middle line is our median. I'm just going to abbreviate with M. And then our end of the box is our quartile 3. And that just so happens to be what they're asking about. It's asking for what percent of the data in plot A is greater than 80. So what percent is to the right of quartile 3? Well, basically we answered it with our diagram here. To the right of quartile 3 would be 25%, or all of this. Nice, so 25%. All right, question number 17. All right, question number 17. What is the mean of the data? So we go ahead and add all those numbers together. Adding all those numbers together, we get 70. Then we need to divide by the amount of numbers. Let's see, we have 2, 4, 6, 7. 70 divided by 7, that should be mental math. That gives us 10. All right, now we need to go ahead and find the variance of the data. If you guys forgot what variance means, well, it's just the mean. We need to find the mean of, well, basically this, the third column, or the mean of squared differences. Mean of the squared differences. All right, but first we have to go ahead and do the rest of this. So let's go ahead and do that. Data value, we just simply go ahead and put in each of those numbers, right? 8, 9, 9, 10, 10, 11, and then 13. That's simply all you do. Next one, we want to find the difference. The difference of what? If you guys forgot, we have to take the data value minus the mean for each of those. So for the first one, we have to take 8 minus 10. That gives us negative 2. Next one, we have to do 9 minus 10. That gives us negative 1. Same thing, 9 minus 10 for the next one. This one is 10, so we have to do 10 minus 10. That gives us 0. Next one is also 10, so 10 minus 10 is equal to 0. 11 minus 10 is equal to 1. And then lastly, 13 minus 10 is equal to 3. All right, so square differences. Now we have to literally, whatever we got in this box, we have to square it. Negative 2 squared, that's just negative 2 times negative 2. That gives us a 4. Negative 1 squared, that gives us a 1. Negative 1 squared, once again, that's just 1. 0 squared is 0. 0 squared, once again, that's 0. 1 squared, that's 1. And then 3 squared gives us 9. All right, so I said before, variance is basically just the mean of the square differences, or the mean of this third column. So first, as you guys know, we just have to add that up. Adding it all up, let's see, 4, 6, 7, we get 16. 16 divided by 7, right? 7 total numbers. 16 divided by 7 gives us 2.28. We want to round to the nearest 1 decimal. 1 decimal place. Remember, rounding to 1 decimal place, we look at the number to the right of that 1 decimal place. Since this is greater than 5, we round up to 2.3. All right, 19. What is the standard deviation of the data? Standard deviation, you literally take the square root of the variance. So literally you take whatever answer you got for number 18 and take the square root of it. So square root of 2.3, that will give you 1.51. All right, so on the test, just be careful. We want to round to 1 decimal place. Looking at this, that's less than 5, so we round down, right, to 1.5. All right, last 2 questions. We have to use this two-way frequency table. So a survey was done to determine the relationship between the class and subject preference. A total of 56 students were surveyed to determine if they liked math, English, social studies, or science. The results were broken down based on whether the respondent was a junior or a senior. So question number 20, what is the joint relative frequency of seniors who preferred math? All right, so be careful what they're asking for, right? So on the two-way frequency table lesson, we learned about joint. Let me just go ahead and rewrite this so you guys have this. Joint. You can think of join or both. Let's see, we learned about marginal. Marginal, that was just one variable. Actually, let me just write both variables. Marginal was just one variable. And then conditional. Conditional relative frequency, that was where maybe first you had to have a requirement. So requirement first. Those 3 different things. All right, so be careful which one they're asking for. All right, so joint means you want to have both of these variables. So both of these variables, what variables are they talking about? Well, they're talking about grade level. That's our first variable. And then subject. So basically this question asks us, let's see, how many students, or sorry, when we see relative frequency, we need a percentage, right? So basically, what percent of students are, once again, it's joint, so we have to say are both, I'm just going to underline that twice, are both seniors and prefer math. All right, so remember with percentages, we need a part over a total. All right, so part over a total. All right, so total is the total number of students. Total number of students is 56. The part, what part of these students are they asking about? They're asking about the students that are both seniors and prefer math. So we just have to go ahead and look at this part right here. Right, 12 seniors lines up with this row of seniors and it lines up with this column of math. 12 divided by 56. Put that in your calculator, you'll get 0.214. Converting that to a percentage, remember we have to move the decimal over twice. So rounding to the nearest whole percentage, that would give us 21%. All right, last question. Question number 21. What is the marginal relative frequency of juniors who took the survey? So remember, marginal, that's just dealing with one variable. So what variable? We're just dealing with the grade level. So we want to find out how many total juniors took the survey. Or, sorry, what percent of juniors? Let me just write that out. What percent of students are juniors? Once again, part over our total. The total is the total number of people that took the survey. So total is 56. And how many juniors do we have all together? Well, if we go ahead and look at this row, right, we have 29 total juniors. So 29 divided by 56. Putting that in your calculator, you'll get 0.517. All right, moving this 2 decimal places, you get 51.7%, but we have to go ahead and round that to the nearest whole number. So 52%. All right, thank you guys for watching this.